Hi, I'm Teacher Thomas. Welcome to A-Level Maths. This is the specimen paper for 9231 Pure Mathematics 1 for the 2020 exam series, question 5. The matrix A is given by A equals 5, K, -3, -4. Requirement A, find the value of K for which A is singular. Referring to the elements of a 2 by 2 matrix as A, B, C, D, the matrix is singular when the determinant equals 0, and we calculate the determinant as A times D minus C times B. For matrix A, 5 times -4 minus -3 times K equals 0. And here I can simplify to -20 equals -3K, dividing both sides by -3. K equals 20 over 3. This completes requirement A. Let's proceed to requirement B. It is now given that K equals 6, so that A equals 5, 6, -3, -4. Requirement B, find the equations of the invariant lines through the origin of the transformation in the xy plane represented by A. To find the invariant lines, I'm going to multiply the 2 by 2 matrix that I'm working with times the 2 by 1 matrix of T, MT, to produce the 2 by 1 matrix of big T, M, big T. As we're looking for lines through the origin, the format of the line equation or equations that we arrive at will be y equals mx. There's no plus c because the y-intercept is 0. For our matrix 5, 6, -3, -4, multiplying by T, MT, producing big T, M, big T. I'll work through the matrix multiplication. My first row on the left, 5, 6, I'll multiply by the only row on the right, T, MT. 5 times T plus 6 times MT equals, notice the resulting matrix has the value big T. And in the next multiplication, I'll take the second row of matrix A and multiply by the column matrix on the right, -3 times T minus 4 times MT. Notice our result is M big T. We're working towards the value of M so that we can plug that into y equals mx, and that will give us our invariant line or lines. We have 3 different variables in 2 equations. I'll do some algebraic manipulation, then divide through to simplify, and we'll see we have only 1 variable remaining. So starting with the second equation, factoring out t, we're left with -3 minus 4m equals m big T. And the first equation, also factoring out t, 5 plus 6m equals t. Now I'm going to divide, and notice that I will eliminate on the left the small t's, eliminate on the right the big T's, and I'm left with the fraction on the left, -3 minus 4m, over 5 plus 6m equals m. This equation simplifies to the quadratic, 6m squared plus 9m plus 3 equals 0. Our 2 solutions, m equals -1/2 and m equals -1, result in 2 invariant lines, y equals -1/2 x and y equals -1 times x, or simply -x. This completes requirement B. Let's proceed to requirement C. The triangle DEF in the xy plane is transformed by A onto triangle PQR. Requirement 1. Given that the area of triangle DEF is 10 square centimeters, find the area of triangle PQR. Requirement 2, find the matrix which transforms triangle PQR onto triangle DEF. For requirement 1, we can calculate area of the transformation as area of our starting shape times the absolute value of the determinant of the transformation matrix. This will produce the area of the transformation. We're given the area of the triangle is 10. We want to multiply by the absolute value of our determinant, recalling from part B that we're working with the matrix which I'm putting down in the lower left-hand corner of the screen, 5, 6, negative 3, negative 4. We'll calculate the determinant as 5 times negative 4 minus negative 3 times 6. The result is 10 times the absolute value of negative 2, which is 20, and our units of measure, centimeters squared. Requirement 2 is asking us to go from the transformation matrix of PQR back to where we started, DEF. This requires us to find the inverse matrix. Using the inverse matrix as the transformation matrix will get us back to the original figure. The inverse matrix is calculated as 1 over the determinant times, using our elements of A, B, C, D, we switch A and D. We change the signs of B and C. We can work through to calculate 1 over the determinant. We've just calculated the determinant on the left side as negative 2. That's the value that's inside the absolute value notation. And taking matrix A, referencing the lower left corner of the screen, we can switch D and A to get to negative 4 and 5. Change the signs of B and C, negative 6 and positive 3, which simplifies to the 2 by 2 matrix 2, 3, negative 3 over 2, negative 5 over 2. This completes requirement C, which completes the requirements for question 5.